Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 35, Differential Equations. A differential equation is an equation that contains a derivative. It does not give you the function directly, but describes how the function changes. Solving one means running integration in reverse of the derivative it holds, and the answer is never a single curve but a whole family, each member differing by an arbitrary constant. Read the order from the highest derivative, spot the type, variable, separable, homogeneous, or linear, and reach for its method, separate and integrate. Substitute y equals vx, or multiply by the integrating factor. From growth and decay to circuits and motion, differential equations are how mathematics speaks about change. Today, order and degree, the standard forms, and the integrating factor, one idea at a time. Here is what you will master today. First, order and degree. Second, forming a differential equation. Third, variable separable equations. Fourth, linear equations. And fifth, the integrating factor, one idea at a time. Let us set the foundation. A differential equation, an equation linking a function to its derivatives. The order, the highest derivative present in the equation. The solution, a function that satisfies it, a family with arbitrary constants. Master line, solving a differential equation is integration in disguise. Now look at the picture. A solution is a family of curves. A differential equation, an equation linking a function to its derivatives. Order and degree. The order is the highest derivative, the degree is its power. The slope field. The equation gives the slope at every point. General versus particular. The general solution is a family with C, a condition picks 1. Now order and degree, precisely. The order, the highest order derivative present in the equation. The degree, the power of that highest derivative once the equation is free of radicals and fractions. The constants, the order equals the number of arbitrary constants in the general solution. The example, d2y by dx squared plus c equals 0, order 2, degree 1. Now forming and classifying. Forming, differentiate the family and eliminate the arbitrary constants. Variable separable, dy by dx equals f of x times g of y. Homogeneous, dy by dx equals f of y over x. Linear, dy by dx plus by equals q. Each type has its own method of solution. Now look at the picture, 3 types, 3 methods. Variable, separable. Gather y on one side, x on the other, then integrate. Linear equations. dy by dx plus by equals q. Multiply by the integrating factor. The integrating factor, it equals e to the integral of p dx. Homogeneous. When dy by dx equals f of y over x, substitute y equals vx. Now the integrating factor, step by step. The linear form, dy by dx plus pi equals q with p and q functions of x. The integrating factor, it equals e to the integral of p dx. Multiply through. The left side becomes the derivative of y times the integrating factor. The solution, y times the integrating factor equals the integral of q times the integrating factor dx plus c. Always write the equation in standard form first. Now a worked example. The equation, dy by dx equals x times y, a variable separable equation. Separate, gather the variables, dy over y equals x dx. Integrate, the natural log of the absolute value of y equals x squared over 2 plus c, so y equals a times e to the x squared over 2. Now match each equation to its method. dy by dx equals f of x times g of y goes to variable separable. dy by dx plus py equals q goes to linear. dy by dx equals f of y over x goes to homogeneous. And the linear integrating factor is e to the integral of p dx. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The order is the highest derivative. Correct. Statement 2. The degree is always 1. Wrong. Only in polynomial form and not always even then. Statement 3. A linear differential equation is solved with an integrating factor. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the degree in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, the number of arbitrary constants equals the order. The trap, reading the degree before clearing radicals and fractions. The second truth, a linear equation must be in standard form before finding the integrating factor. The second trap, forgetting the constant of integration when solving. Now test yourself. Answer in your head before the reveal. That is how G-Speed is built. Here we go. Question 1. The order of a differential equation. The highest derivative. Question 2. The method for dy by dx equals f of x times g of y. Variable, separable. Question 3. The integrating factor for a linear equation, e to the integral of p dx. Question 4. The constants in the general solution, equal to the order. And question 5. The substitution for homogeneous equation, y equals vx. Let us gather it all in one breath. A differential equation links a function to its derivatives. Order is the highest derivative, degree is its power. Variable separable, separate the variables and integrate. Linear, di by dx plus pi equals q multiply by the integrating factor. The integrating factor equals e to the integral of p dx. Next class, probability. The mathematics of change. A differential equation is a sentence about change. It tells you not where a thing is, but how fast it is moving, and asks you to reconstruct the whole journey. Solve it, and you never get one answer but a family. Each curve, a shift of its neighbor by an arbitrary constant, and a single initial condition finally pins down the one you want. Read the order from the highest derivative, name the type, and apply its method, separate and integrate, substitute y equals vx, or multiply by the integrating factor, e to the integral of p dx. This is the language in which physics, chemistry, and economics all describe the world in motion. Next class, probability. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time. You will crack G. I will see you in the next class.